Have you ever really stopped to think about how we measure the space inside of things? Not just, how long they are, but how much they can actually hold? Well, today, we're diving deep into that three-dimensional world of volume.
So, picture this. You've got a brand new swimming pool in your backyard. It's empty. Before you can even think about filling it up, you have to answer one really important question. How much water is this thing going to take? That, right there, is a question of volume, and we're going to figure it out. Okay, so to tackle a question like that, we've got to start with the basics, right? We need to get a super clear idea of what we even mean when we say the word volume.
It's actually pretty simple. Volume is just the total amount of space packed inside any three-dimensional object. It could be a shoebox, an aquarium, or, our swimming pool. Volume tells us its total capacity.
But how do you measure that empty space? Well, we use something called cubic units. And the best way to wrap your head around this is to imagine filling up a box with, say, little sugar cubes. The total number of cubes you could cram in there to fill it up completely, that's its volume. And that's exactly why we use units like cubic centimeters or cubic meters. We are literally counting cubes. To really get this, we're going to start with the most basic 3D shape there is, the good old-fashioned box. You've seen a million of them, but in geometry, it has a slightly fancier name, the rectangular prism.
So, what is a rectangular prism? Well, it's basically any solid thing with two identical flat ends and straight sides. I mean, think about it. Your phone is a prism. A book is a prism. They are absolutely everywhere, which makes them the perfect place for us to start.
And here's the best part. The formula for finding its volume, it's just so simple. It's just the length times the width times the height. That is it. So elegant and so powerful.
So really, it all comes down to a super simple four-step process. You find those three key measurements, length, width, and height, and then you just multiply them all together. Let's actually try it.
Okay, let's jump back to our swimming pool. We've got the numbers. It's 5 meters long, 4 meters wide, and 1.5 meters deep, which in this case is just another word for height. So how do we find the volume?
All we got to do is plug those numbers straight into that formula. We put 5 in for length, 4 for width, and 1.5 for height. First up, 5 times 4, that gets us 20. Then we just have to multiply that 20 by 1.5, and that gives us our answer.
30 cubic meters. That's it. That's how much water you need to fill that pool. See? Once you know the formula, it's actually pretty easy.
All right, so boxes are pretty straightforward. But the world isn't just made of boxes, right? What happens when a shape starts with a flat bottom, but then all the sides taper up to a single point at the top? I'm talking, of course, about pyramids. You know this shape. It has a flat base, kind of like a prism, but instead of straight sides going all the way up, it's got these triangular faces that all rush up to meet at one single point on top. We call that point the apex.
So this brings up a really interesting question. Let's say you have a pyramid and a prism, and they have the exact same size base and the exact same height. How are their volumes related? I mean, is it half? Is it something weird and complicated?
You might be expecting some crazy fraction, but the answer is so clean and so cool. A pyramid's volume is exactly 1/3 of a prism's with the same base and height. And this reveals this just fascinating relationship in the real world. Imagine you had 3 identical pyramids. If you filled each one with water and poured them into a prism that had the same base and height, that prism would be filled up perfectly. Not almost, not close, exactly. And that awesome little rule? Well, it leads us directly to the formula for a pyramid's volume. You start with the exact same formula as the prism, length times width times height, and then you just divide the whole thing by 3. It's really that simple.
Okay, let's put this new formula to the test. Let's imagine we've got a big pyramid. Its base is 12 meters by 14 meters, and it's 20 meters tall. What's the volume?
We follow the exact same process we did before. First, we figure out the volume of the box the pyramid would fit inside. 12 times 14 times 20, which is 3,360. But because it's a pyramid, we have to do that one last crucial step. Divide that number by 3. And there we go. The volume of our pyramid is 1,120 cubic meters. It's the same logic, just with one extra little step at the very end.
Now, this isn't just some abstract math problem. The reason any of this really matters is that these two simple shapes, the prism and the pyramid, are basically the building blocks for the world all around us. I mean, seriously, just think about it.
Office buildings, shipping containers, they're just giant prisms. The roof of a house can be a prism, a tent is often a pyramid. Famous landmarks are pyramids. Once you start looking for them, you see these shapes literally everywhere. And now you actually know how to figure out the space inside them.
So let's bring it all back. At the end of the day, volume is just the amount of space inside an object, counted in little stackable cubes. It doesn't matter if it's a simple box or a pointy pyramid, that core idea is always the same.
So, we've pretty much mastered shapes with straight lines and flat faces, but that leaves one big, glaring question on the table, doesn't it? What happens when you throw curves into the mix? What about stuff like soda cans, or pipes, or ice cream cones? How in the world do you measure the space inside them? Well, that's a question for another time.